Hello and welcome back to this Fundamentals of Machine Learning tutorial. In this video, we'll be talking about classification. We'll start with logistic regression. So, from the previous examples, we'll be using Google Colab. So go to Google Colab, click on Start a New Notebook. Or you can click on File and New Notebook. So we need to import the necessary libraries. We've used most of these before. We have pandas, numpy, plot, seaborn for advanced visualization. We'll use the Tress splits, standard scalar. Now the new thing here is logistic regression, confusion matrix, accuracy score, and classification reports. So if you want to learn about these new things, you can see the videos on classification and evaluation. So let's import this. Run it. So now let's load the Titanic dataset. So from this file, which I'll put in the link below or in the comment section. So you can put URL equals to this, so it's going to be stored in the URL variable. So you can check the link in the video description. Okay, so the variable URL has this. And remember, you can use the .read CSV to read a URL. So data equals pd.read CSV, and we want to print out the first column names and the first 5 rows in our variable. Okay, sorry, this was not. So I'll run this again. So yeah, so wait to see that it has run. So with this green check mark here. So I can run this now. So yeah, so these are column names and the first 5 rows from passenger ID, survive, P class, name, sex, age, siblings, patch, parent-child, tickets, fare, cabin, and packed. So data preprocessing. So we'll continue with what we learned with in data processing. So you should know how to fill in missing age or convert to categories or binary variables. You should be able to drop columns and so on. So let's use this. So here we have remember our variable is stored in data, so we want the age column. I want to fill all the missing age values to the median of all of the age row. So it will take the age column, get all the median, and it's going to fill this age column with that particular value. So if you remember, in place equals to true is just going to happen on the particular data set, this data here. So we can also convert sex to a binary variable. So remember, it's in the data set, it is male and female. So we want male to be 0 and female 1. So if you remember from the data preprocessing video. And remember, we can also drop columns. So some of these columns aren't really necessary to predict whether a passenger will survive or not. So we can delete them. So we don't really need passenger ID, the name, the ticket, the cabin, and backed. So this doesn't have to do with whether or not the person will survive. So you can just drop these columns. So let's preview the modified data sets. So here you go. So now sex is now 0, 1, 1, 0. So this is male, female, 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 0. So if you look before, it was written this way, male, female, 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 male. But now we want it this way. So yeah, that's a computation. So what else did we do? The median age. So all the parts that were missing. So in the first 5, none of them are missing. But if any was missing, it would have been replaced with the median value. And you can see now we don't have some of these columns anymore. These columns and the passenger ID column. So the next thing now, we want to split our data set. So let's remove the survived column. So remember, it depends on what you're trying to classify. So based on someone's age or gender or the other features that are in the data set, can they survive? So we want all of X to be those features we kept and the Y, the output, to be survived, just like we did in linear regression. And remember from the linear regression video as well, if you want to split your data sets, remember you divide your data sets into two. You can use 80% for training, 20% for testing. So 80%, the one for training is just you teaching the model what it's used for, and then the 20% you want to assess the performance to see how well your model is doing. Did it learn well? So that's what it's for. So let's take this. And we can also optionally scale features. So if you want it on a similar range, so you can try this way. So now our X is this 4, 1, 2, 3, 4, 5, 6, this 6 column, and our Y is this survived column. So we want to use this here to see whether the person survived or not. So the passenger class, the gender, the age, siblings, parents, child, and their fare. So can these be used to predict survived, whether or not the passenger survived? So let's build and train the model. So train a logistic regression model. So logistic regression is a fundamental classification algorithm suitable for binary outcomes like survival. So the same way it was for linear regression will be the same way for logistic regression. Model equals to logistic regression. And remember, .fit is used to train. So you want to train each of the X train with Y train. So remember, X train is like the inputs, the features, and Y train is the outputs. That's the survived column. So remember, we're also separating it with train and test, because train is what we're using to teach it, and then the test is the one left aside for testing. So now we can make predictions. So remember .predict. You can use .predict to make predictions with the test sets, and we will also use accuracy score confusion matrix to evaluate the model. So let's get this. So y pride equals model that predicts x test. So now we're going to use that x test. So remember, we wouldn't show it the correct answers, so we'll give the model the inputs and let it predict, and we'll then use the actual output, which is y test, and compare it to what it predicted, y pred. So what the model is predicting will be stored in y pred, and then we'll check the actual y test with this, and with this you can get the accuracy score. So you can check the previous videos on evaluation. So you remember, accuracy score is just how well the percentage you got right. So if you have 100 things and you got 90% right, your accuracy will be 90% or 0.9. So let's run this. So this is pretty okay. Our accuracy is 0.79. So it's good to have an accuracy score that's close to 100. Confusion matrix. So if you remember, true positive and true negative as well, you can plot the confusion matrix. So depending on how many data sets you had, how many data you had, so it got true positive 90, true negatives 53. And you can also calculate precision, recall, F1 score for all of them as well. So let's also look at how you can use all the classification algorithms. So it's still the same way. You're going to load your data the same way. You're going to preprocess it the same way, split the same way. You can scale the features if you want. Then when it comes to training the model, with logistic regression, remember you use logistic regression. If you want to use a decision tree classifier, you then use decision tree classifier random states 42. So if you remember decision tree, it's a flow-like tree structure. So each internal node represents a test and an attribute. So you can check the video on classification explaining each of them. And remember, random state ensures that the splits that you generate are reproducible. And we also have SVM. So with SVM, from sklearn or SVM, you want to import SVC. SVC here, kernel equals to linear, and random say equals to 42. So SVM, remember, a powerful classification method that works by finding the best hyperplane that separates data into two categories. Kernel specifies the type to be used in the algorithm. So linear is one of the simplest forms, which means the decision boundary is a straight line or a hyperplane. We have random forest. So from sklearn.ensemble, import random forest classifier. So this is how you put it here: random forest classifier, and then n underscore estimators equals 100, random say equals 42. You can put the variable, you can put it in this variable here. So remember, it's the name of the variable you use, and then you put dot fits x train y train, same way. And to evaluate as well, so it's still the same way as well. So what you call the model dot predicts, what you call the model dot predicts, and you can get your classification score. So for example, for this one, instead of storing it in ypred for all of them, you can differentiate them. Remember, another variable name like this, ypred underscore lr. So when you're trying to get the accuracy score, you use ytest, which is what you already have, and what you called your ypred, so ypred underscore lr. So this one is ypred underscore dt, and so on. So you can remember variables, you can name them what you want. So thank you for watching this particular video, logistic regression. If you have any questions, feel free to leave it in the comments below, and then I'll reply you.